Hey, what's up? Welcome to this new video. This one is paper 3-2 of February-March 2021 from A-Level Math paper 3. Now in this video, I will try my best to explain everything as simply as possible. And the reason is because as we expect, the exam questions will not be the same as the previous years. It will always change, right? So because of that, it is also important to understand the steps and everything that we could use to attack or approach each question as given to you on the exam. So with that being said, let's move on to the questions. Number one. Now the first step is we have to read the question and understand what they are asking us for. For example, here we have to solve this equation. Give your answer correct to 3SF. Now there's two things here. So solving means what? Solving means finding the value of x. That's the first thing. And then give your answer correct to 3SF. So definitely this is also something we have to keep in mind while solving the question. Now, to find the value of x, we have to find a way to make x become the subject in this equation right here. So one thing we observe is that here we have ln, and ln. So how can we combine or get rid of ln so we can have x as the subject? So let's look at a few properties for logarithms. For example, here we have this. So we have 3 ln of x. Now we know that we can send this to the top by the laws of logarithms. That will be ln of x power 3. That's the first thing we could do here. Okay, so let's do this. So you have ln x 3 minus 3 equal to ln of x power 3 minus ln of 3. Okay, so let's move on to the other steps. Let's see what do we have. Now here too we have this one. Here we have ln of a, for example, minus ln of b. Now because these two are the same, we can combine them together. So that will be ln, here we have a, and because we have minus, that will basically be divide by b. So that is a way to combine these two together. So now just by comparison, you can see we can combine these two together as well. That will be ln. Here we have x power 3 minus become divide by 3. Here we have ln x cubed minus 3 as before. Now something we realize here is that because we have ln on both sides, they're the same thing, right? We can cancel them out. That's something we can do to simplify this equation. The next thing, let's say we have this now. We have x power 3 minus 3 is equal to x power 3 over the value of 3. Now what is this? This is basically the same thing over 1. Now, the following thing we can do is we can just simply cross multiply, right? You will have 3 x power 3 minus 9 is equal to x power 3. Now solve, we have to find x obviously, so send x to one side, you will have 3 x power 3 minus x power 3 is equal to 9. Now 3 minus 1 will be 2x power 3, that will be 9. So x power 3 will be 9 over 2, which is 4.5. Now finally, to find the value of this, that will be cubic root of 4.5. So x will be what? So let me check. So cubic root of 4.5. That should be 1.65096. However, your answer needs to be in 3SF as required by the question, so don't miss that. So it will be 1.65 as your value of x. And that will be your question number 1 for this paper. Now let's move on to question number 2. So now we have a polynomial ax cubed plus 5x squared minus 4x plus b, where a and b are constants. Okay, that is very simple to understand. Now, polynomial means basically an equation, a expression in terms of x here. That's what it means, nothing scary. It is denoted by p of x. So this whole thing here, we can call this p of x. That's the first line given to you. Now, it is given that x plus 2 is a factor of p of x, and that p of x, when p of x is divided by this one, we have a remainder of 2. So pretty easy. We just have to understand what it means, right? So it is given that this is a factor. So when it is a factor of p of x, it means that the remainder will be 0. That's what it means by the remainder theorem. So the idea is that let's find for what value of x is p of x have a remainder of 0. So let's see. If x plus 2 is a factor, we can equate that to 0, which is the same thing here, right? Which means x will be equal to minus 2. So when x equal to minus 2, it means that the remainder is 0. Now how can we write this in the equation? So very easy. We know the equation is equal to p of x. For example, if p takes in the value of x, which is minus 2, it has to give you 0 for the remainder. That is my equation number 1. So let's replace this value in this equation. Let's see what happens, right? So you will have, so here we have a minus 2 power 3 plus 5 minus 2 power 2 minus 4 minus 2 plus b, and this is going to give you 0 according to the question. Now simplify, that will be what? Minus 8 a plus, this is 420 plus 8 plus b, that will be this. So b minus 8a, that will be minus 28. This is my equation number 1. Now let's move on to equation number 2. Now when p of x is divided by this one, it has a remainder of 2. So it means that this is x plus 1 have to equate to 0, x have to be minus 1, right? So when p of x takes in the value of minus 1, the remainder is now 2 by the remainder theorem. Now same steps, we just have to replace this back in the main equation. That will be minus 1 cubed plus 5 minus 1 square minus 4 minus 1 plus b have to give you 2 for this one. This is also given to you by the question, so nothing magic here. It's just you have to derive those two equations in order to solve for the value of b and a, of a and b, right? Simplify, that will be minus a plus 5 plus 4 plus b equal to 2. So b minus a has to be 2 minus 9, that should be minus 7. So b minus a, that will be minus 7. That will be your equation number 2. Now because we have the two equations, we can solve them simultaneously, right? Here we have b and here we have b. So let's replace them in each other. For example, let me take 1, put this into 2. So b is also given by what? So let's make this become subject. So b is equal to minus 28. Send this over here, become plus 8a. So same thing here. b is also given by minus 28 plus 8a minus a equal to minus 7, right? Now let's follow up with this. So we have this minus this will be what? That will be 7a. Here we have minus 7 plus 28. So 7a, that will be what? So let's check. Plus 28, that should be 21. So 21, a has to be 21 divided by 7, and that should give you the value of 3. But always double check, because why not? That will be 3. And finally, we have to replace back in the main equation to find the value of b. So b has to be minus 28 plus 8 times a for this one. That will be minus 28 plus 24. That should be minus 4. So let's confirm the last two values. The final value will be a is equal to 3 and b is equal to minus 4. And that will be step by step of how to solve these kind of questions for question number 2. So let's move on to question number 3. So by first expressing the equation tan x plus 45 equal to 2 cot x plus 1 as a quadratic equation in tan x, so we have to change everything here in terms of tan x. We have to solve the equation for the values of x between this and this. So if you look at the quadrants, you know exactly that x have to be in the first and second quadrant. So this is just something good to know for now. However, let's proceed by simplifying this whole equation in terms of tan x. So the first thing we realize is what? The easiest thing is this one, right? So what is cot x? Let's write this here. Cot x is simply equal to 1 over tan x. So it's something we can use in the simplification of that equation. Now for this one, something we know is that if you have tan a plus b, if you expand, that will give you what? Tan a plus tan b over the value of 1 minus tan A and tan B. This is also available in the F19 formula sheet. If you guys want to learn about this formula, it is available right there. Now here we have what? Here we have tan of x plus 45. So by comparison, A is x, B is 45. Just replace in that main equation to simplify this, right? You will have tan of A is x, tan of B is 45, divided by 1 minus tan of A is x, and tan of B is tan 45. Okay, so now let's see how can we simplify this some more. Something we do see that we have tan of 45. Let's see what is that value. Tan of 45, that is 1. So that is good news. That is 1. And 1, we can just simplify this. So this will give you tan x plus 1 over the value of 1 minus tan x. Right. So this side become this. Now for this side, let's see what happens. Let me do this over here. Why not? So have some space. Let me simplify. We have 2. So 2 cot x will be 2 over tan x plus 1. That will be 2 plus tan x over tan x. If you were to simplify, right, because here we have 1 is also 1 over 1. Because we have different base, we have to multiply them by each other. So tan x times 1 will be tan x. And then we have to cross multiply. This will be 2 and this will be tan x. That's how you can combine these two to become this. Now we just have to replace back in the main equation. So let's see what do we have now. So on the left hand side we have tan x plus 1 over the value of 1 minus tan x equal to the right hand side will be 2 plus tan x over the value of tan x. Right, so now as always when we have something like this, for example A over B is equal to C over D, well, I mean the first reflex is we can always try to cross multiply. So same thing here, let's try to cross multiply to see what happens. So on this side you will have tan squared x plus tan x is equal to, so let's take 2 first. 2 times this will be 2 minus 2 tan x, and this time this will be plus tan x minus tan squared x. Okay, now let's see how can we simplify some more. Let's send everything to one side. You will have this plus this, that will be 2 tan squared x, and here we have what? Here we have tan x, here we have tan x, so they will cancel out. Send this over here, become plus 2 tan x, and then we have minus 2 is equal to 0. Right, now because we have 2, 2, 2, we can divide by 2 everywhere. You will have what? Tan squared x plus tan x minus 1 is equal to 0. Now again, if you don't like to work with those big terms, we can always say let u equal to tan x. That will give you u squared plus u minus 1 equal to 0. Right. Now, of course, this one we have to solve for the value of u first. We can use the formula if you want to. So u will be minus b, that will be 1, plus minus b squared minus 4 times a times c. Everything divided by 2a will be 2. Minus 1 plus, so 1 minus 4 times 1 minus 1. That'll be 5. So minus 1 plus minus root of 5 over 2. Minus 1 plus root of 5 divided by 2, that will be this. So first value of u will be u is equal to 0.618033988. That's the first value. Or let's see what else can we have. Or we can have minus 1 minus root of 5 divided by 2. That will be minus 1.618033989. So we have two values of u. But now again, we're not trying to find the value of u. So finally, let's bring back this one to the equation. So we have tan x is equal to 0.618, or tan x is equal to minus 1.618. Now when tan is positive, it will be in the first quadrant, and in the third quadrant. But we don't need the third, we only need the first. Pretty easy. We can find this directly by taking x have to be tan inverse of the value of, on this side, let's see what happens. Tan inverse of 0.618, that should be 31.7. So 31.7 degrees will be the first value. And for this one, let's see what happens. That will be, so when tan is negative, it will be in this quadrant and in this. However, we only need this one because, as you can see here, it is only between 0 and 180. We don't need anything else. We need these two only. Right. So for this one, because it is negative, we'll use a fake angle, which is 180 minus theta. So let's first find the value of theta. Theta is not the answer. It is tan inverse of the positive value on the other side. It is not negative here because it is not the answer yet. I'm just using this to help me find the value of x. 1.618, that will be 58.281. So 180 minus theta for the value of x, right? That's what we were trying to find. That will be 121.7. So finally, we realize we have two values of x. So the first one is equal to 31.7 and 121.7 degrees. So that will be your question number 3, for which you have to first simplify using this formula, and then step by step try to simplify to form a quadratic equation, then solving these kind of equation to find the two values of x. And that is your question number 3. Now, so let's move on to question number 4. So the variables x and y satisfy the differential equation. So here you can see we have 1 minus cos x dy by dx equal to y sine x. It is given that y equal to 4 when x equal to pi. That is good to know. I think we'll use that later on in the question. So part A, we have to solve the equation, and then we have to express y in terms of x. So exactly you have to learn, or have to see exactly what the question is asking you to do in the end for the full marks. So one by one, the main idea at first is to send all the x to one side and all the y's to one side. For example, here I can send y over here, so that will be 1 over y, that will be dy. And send x over here, you will have sin x over 1 minus cos x. And that will be dx, right? So you can just cross multiply, this will go up, dx will become here, and divide by y will become here, that will go away, and this will become like this. Now obviously we have to solve this integration to find the values of y in terms of x. So for this left hand side is pretty easy. So we know this is simply equal to ln of y, right? Now for this one, if you observe, this one I know at first it might seem kind of tricky, kind of hard, but the main idea is that pretty simple. So we have sin x over 1 minus cos x. So in this case we have to use substitution. And the reason why is because whenever you have d of dx of one of the term in the other one, we can use that. For example, what is d by dx of the base? It is 1 minus cos x, that will be, this is 0, here we have minus, then become minus sin x, that will be sin x. As you can see, the d by dx of this term is equal to this, which is the same as the top. So it has the d by dx of one term is equal to the other term. So whenever we have a situation like this, we have to use substitution. So the main idea will be what? Let u is equal to 1 minus cos x. So du by dx, that will be what? That will be sin x. So finally, we can say dx have to be du divided by sin x. Pretty easy. Now just replace this in this by this, right? You will have integration, let me use red, sin x on top. On the base, you will have u here, and that will be du over sin x. Now, very simple. We can see we can just cancel these two. So you'll have integration of 1 over u by du. That will be ln of u. Now replace everything back in the main equation. So in the main equation right now, we have what? On the left hand side, we have ln of y is equal to ln of u and plus c for the constant of integration. Now we have to find this value of c. Of course, we have to use the given values right here. So there's always a reason why they give you something. We have to use them. That's the main thing we have to know. So here you have what? Ln y is equal to 4. Ln, this is u is what? U is equal to, here, 1 minus cos x. So 1 minus cos this plus c. That will be ln of 4 is what? It is ln. Now what is cos of pi? So radians, cos of pi is equal to minus 1. So 1 minus minus 1 is 2. That will be 2 here. And plus c. So finally, c will be ln of 4 minus ln of 2. That will be ln 4 here. Minus become divide by 2. That will be ln of 2. So c is going to be ln of 2 as the answer. So finally we conclude ln of y is equal to ln of 1 minus cos x plus ln of 2. So now this is the first step. Now again, we have to see what is the question asking for, expressing y in terms of x. So here we have ln, ln, and ln. So let's try to simplify this side first. You have ln here of y. So combine them. So 1, that will be 1 minus cos of x, plus becomes multiply by the value here will be 2. Now because we have ln on both sides, they will cancel out. So you have y equal to 2 minus 2 cos x. So here you go. This is y in terms of x. That will be part A of your question. Now let's move on to part B of the question. So here we have to sketch the graph of y for this domain. Now again, whenever you have to sketch something, what do I advise? Even if it is only for 1 mark, we can do this step by step. If you can see, the equation that we have seen is y is equal to 2 minus 2 cos x. Now again, you can always use your mind to just do this directly. However, I always advise to use what? To use a table of values to help you for this kind of question, because you don't want to make any silly mistakes, right? So let's begin. We have x and the value of y. We can start from 0, why not? And then we have x here. So if you have only x, which is 1x, we start with the angle of 90 degrees, which is pi by 2. Then we have pi, 3 pi by 2, and then we have 2 pi. The reason why I choose the interval of 90 is because I want to work with exact values. That's the main reason why. So let's do this. So we have radians here, obviously. So 2 minus 2 cos of 0, that will be 0. And then I have here will be pi by 2. Pi over 2, that will be 2. Then we have pi, so basically pi over 1, that will be 4. Then we have 3 pi by 2, so 3 pi over 2, that will be 2. And finally 2 pi, let's see what happens. 2 pi, that should be 0. Here you go. So these are the values that we have to work with for the graph. So again, the reason why I do this is because I can confirm, I can be sure that my values are okay for the graph. Let me just draw the axis real fast. Now, since this one is only a sketch, we don't need to be exact with the values. It's okay. We can just try to make it as accurate as we can, but it doesn't need to be exact. So let me label this one as well. So that should be what? Pi, 2 pi. Let me put this here. Why not? That will be 0. That will be pi by 2. That will be pi, 3 pi by 2, and that will be 2 pi. That will be x. And as you can see, y between the value of 1, 2, 3, and 4. That will be y. So here we have the value of 1, 2, 3, and 4. The first value is 0. Again, it does not include the value of 0. We can just use something like this, right? And then that will be 2. 2 will be right here. and we have 4. Of course, you can use a ruler to make sure that it is exactly where it's supposed to be, but again, it's only a sketch, so we can just freehand the whole thing, not a big deal. This one, and then here we have 0 again. So 0 does not include this value here. We can just put a empty circle. Now again, we can see that here we have the value here. So basically y is equal to minus 2 cos x plus 2. This is your baseline. We can always draw this line to use as an indication, right? As an indication to help us kind of know where to change direction for the curve. This will be the max point. It will be something like this. This will go here, and here you have to switch direction. You see? That is the line that helps us to know where to switch direction. That will be this, and bam, switch direction. So here you go. This will be the shape of this curve. Again, you can do this directly, but as always, I like to use a table of values so I can confirm the exact values for my curve. And label this as y equal to 2 minus 2 cos x. And this is your question number 4. Okay, now let's move on to question number 5. So here we have to express root of 7 sin x plus 2 cos x in the form of this. Okay, where r is a positive number and alpha is between 0 and 90. State the exact value of r and give this correct to 2 decimal place. Okay, so just be careful to see what they are asking you for. Now, pretty easy. How do you find the value of r? R is equal to simply square root of this value squared, that will be 7. This value squared, that will be 4. So r will be root of 11. That's the first thing to know. Now alpha, pretty easy. That will be tan inverse of this value here, which is 2, over the value of root of 7. Okay, so let's see what do we get in terms of 2 decimal place. 2 divided by root of 7. That will be, this is radians, so we have to use degrees here, I think. Yeah, degrees. That will be 37.1. Sorry, 37.09 correct to 2 decimal place. So the conclusion is this is the same thing as root of 11 sine of x plus 37.09. And that will be part A of the question for 3 marks. So pretty easy. Okay, so let's move on to question part B. So hence, we have to solve this equation. So when you see hence, means we have to use the answer that we have previously. So from what we have seen, we had a root of 7 sin x plus 2 cos x that was transformed into root of 11 sine of, we had x plus, I think 2 dp was 37.09. That's what we have for the first part. Now by comparison, you can see that the only difference is the x here has become 2 theta. That's the only difference. Now we can just do the same thing, replace. So from here we realize that this is the same thing as root of 11 sine of x became 2 theta plus this equal to the value of 1. So we have to solve this equation for the value of theta between 0 and 180. So one by one, let's first make sine become the subject. You will have sine 2 theta plus 37.09. That will be 1 divided by root of 11. Now because sine is positive, we know that it will be in the first one and in the second one. Right, that will be the value of the angle. Let's call it angle. And this is 180 minus angle. Right. So let's see what can we have here. We have 2 theta plus 37.09 has to be sine inverse of 1 over root 11. Sine inverse of the answer should be 17.5. So 17.5, but also this one is 180 minus 17.5 should give you 162.5. Now, because here we have 2 theta, what I try to do is I try to add 360 to each of those values just in case we don't miss any values for the final answer, just in case, right? We don't know. So 17.5 plus 360, that will be 377.5. That will be 522.5. Right, so we have these four values to work with to solve this one. So one by one, we have to first make 2 theta become the subject. So we have to minus these values. So this minus this value, right, to make it become subject. So 17.5 minus 37.09, that should give you minus 19.59. Okay. Next will be 162.5 minus 37.09. That will be 125.41. And we have 377.5 minus 37.09. That will be 340.41. 522.5 minus 37.09. That will be 485.41. So let's find the value. Theta will be what? Minus 19.59 divided by 2. That will be minus 9.8 degrees, right? 125.41 divided by 2. That will be 62.7 degrees. And here we have 340.41 divided by 2, 170.2. And finally, 185.41 divided by 2, that should be 242.7 degrees. Now the last step is pretty easy. We just have to see, okay, the value of theta should be between the values of 0 and 180. So according to this domain, we have to cancel this one. Cancel this one. So theta will be the value of 62.7 and 170.2 degrees. So you always try to provide the answers for the angles in 1 decimal place for this question. And that will be your question number 5. Now let's move on to question number 6. Let f of x equal to this equation or this expression. We have a fraction here where a is a positive constant. That's something good to know. Now part A, we have to express f of x in partial fraction. Now the first thing we have to look at before doing anything is look at these two. Right, these two. Now we realize that the power of x for those two, it is 1, right? So here we have x, here we have x. Now because of that, it is a pretty simple question. We can just say, let f of x equal to, let's call this big A over the value of 2x minus a plus big B over the value of 3a minus x. So the reason why I can do this again is because of the power of x is 1. It is called linear. Because of that, I can just expand this to something like this. For example, now I can let me write this here. F of x was given to you by 5a over the value of 2x minus a and 3a minus x is going to be a over 2x minus a plus b over 3a minus x. Now we can just take this, multiply by those two. Let's see what happens. So this will simplify to what? We have 5a here. A over this times this will give you a times 3a minus x. And b over this multiplied by this will give you b times 2x minus a. Because if you think, we have this multiplied by this, so this and this will cancel out. And this one will be, this and this will cancel out as well. So you will have this equation. So one by one, we have to try to solve for the value of this one and the value of this one, right? So let's see. Let me first choose a value of x. For example, here I can choose let x be what? Be the value of 3a. You will have 5a is equal to a times 3a minus 3a. That will be b. That will be 2 times x will be 3a minus a. Right, you will have 5a is equal to, this will be 0, right? That will be 0 plus b, and this will give you 6 minus 1, that will be 5a. So we have 5a is equal to 5ab. So by just simply dividing by 5a, you will have 1 is equal to the value of b. That is my first value here for this equation. Now let me rewrite this down again. So we have, right now we have 5a is equal to a, 3a minus x plus b is 1, 2x minus a. Now for this one, pretty easy. Let me, you can try many things, but let me try a, x equal to 2. So x equal to a over 2. Okay, so you will have what? Let's see. So here you will have 5a, same thing. That will be a. That will be 3a minus a over 2. That will be 1. 2 times x will be a minus a. So this will become 0. And here we have 5a. That will become, so 3a minus half a, that will be 2.5a, right? And then finally, we can just divide by a on both sides. This will go away. Divide by 2.5, you will have 2 here, and that will be a. You can check. 5 divided by 2.5, it will be 2, right? So a will be 2. So finally, we conclude what? We conclude that f of x can also be written as a is 2 over the value of 2x minus a plus 1, which is b, over the value of 3a minus x. That is f of x in terms of partial fraction. Again, the first thing we'll look at is what? It is these two at the base. If the power of x is linear, which is x power 1, we can simply rewrite this as something like this. And then solve one by one for the values of a and b. And then express this as a partial fraction. That is part A of the question. Now let's move on to part B of the question. So hence, again, you can see hence means we have to use the previous answer to find this one. So we have to show this become this. So now we know that this f of x can also be written as 2x minus a plus 1 over 3a minus x by dx. So let's try to solve one by one. So the idea is that we can always break this down into two pieces. That would be 2a, and here we have 2x minus a, plus, here we have plus, and that will be 2a, 1 over 3a minus x by dx, obviously, for those two. Let's first look at this one. Right, so for this one we have 2 here. 2 is only a multiple. We can leave this outside, no big deal. And here we will have 1 over this, so very simple. That will be ln over the whole thing at the base. That will be 2x minus a. The reason we can do this is because this is linear. That's why it is possible, okay? And then after doing this, we have to divide by d of dx by the value inside. That will be 2, right? Now next step, plus. Here we have 1. 1 is the multiple. Here we have 1 over this, so that will be ln of the whole thing at the base again, because it is a linear factor. We can do this. Next thing is divide by d by dx of this. That will give you minus 1, right? So simplify, cancel out. You will have ln of 2x minus a minus ln of 3a minus x between the limits of 2a and a. Let's see what happens. So on the one side you will have ln. That will be 2. X was 2a minus a minus ln. That will be 3a minus 2a. That's the first part. Then minus, here we have ln of 2a minus a minus ln of 3a minus a. So one by one. For this one will become ln of, so we have 4 minus 1 is, so 4a minus a, that will be 3a minus ln of a, right? And then this one will become ln of a minus ln of, so 3 minus 1 is 2, right? 2a. Okay, so now we have this. Now we can try to combine them together. So let's write everything down. You will have ln of 3a minus ln of a minus ln of a plus ln of 2a. Now as you can see, since everyone has the same ln, we can combine them together by the laws of logarithms. So we write a big one. Here we have 3a. We have minus. You will go divide a, minus, divide a again, plus, we can multiply by 2a. So that will give you what? Let's see. That will give you the value of, cancel out here. And this will give you ln of 6. And this is exactly shown as required. So that's the main thing. Step by step, we have to show exactly what it is required by the question. And that is your question number 6. Now let's move on to question number 7. So we have two lines have equations r equal to this and r equal to this. Now part 1, we have to show that the lines are skew. Now skew means, so what is the meaning of the lines of skew? So there's two conditions that we have to show so that the lines are skew. The first one is it is not parallel. That's the first condition. And the second one is it does not meet each other. So we have to show each of those so that we can prove the two lines are skew. Okay, so let me first show the first one. So for the first one is pretty easy. So by observation here, for this one, you can see that the direction of this one, so 2 minus 1, this is not a multiple of this direction. So because of that, it will not be parallel, if that makes sense, right? That's the first one. Now it does not meet each other, so pretty easy. We can first rewrite those two equations. For example, let me rewrite this one. So let's expand the brackets, right? That will be what? R is equal to 1 plus 2s, 3 minus s, 2 plus 3s. And for this one, r is equal to 2 plus t, 1 minus t, 4 plus 4t. That will be the two lines. Now, for us to prove that they do not meet, we have to first assume. Let's assume that they meet. So assume that the fact that we trying to say they meet. So what happens when they meet? If they meet, this will be equal to this. Let's do this. That will be 1 plus 2s, 3 minus s, 2 plus 3s have to equal to 2 plus t, 1 minus t, 4 plus 4t. So let's equate and see if all the equations is valid or not. So the first one is 1 plus 2s is equal to 2 plus t. So t has to be what? T has to be 2s minus 1. Now for this one, 3 minus s is equal to 1 minus t. So replace t. In here you will have 3 minus s. 1 minus t will be 2s minus 1. That will be 3 minus s. That will be 1 minus 2s plus 1. Now simplify, let's see what happens, right? So let's send s over here. That will be minus s plus 2s. That will be s. 1 plus 1 minus 3. That should be minus 1. Right, if that makes sense. Now for this one, t has to be 2 times minus 1, minus 1. That should be minus 2, minus 1. That should be minus 3. Now for these two values that we have found, t is this, s is this. Let's replace those back in this one to see if it is valid or not, right? So you will have 2 plus 3s is minus 1 is equal to 2 minus 3. That should be minus 1. Now for this one, let's see what happens. So here we have 4 plus 4t. t is minus 3. That will be 4 minus 12. That should be minus 8. So these two are not equal. So since, you can say since this is not equal to this, by those two conditions, since you know that this does not meet here, and this is not parallel, we confirm that by 1 and 2, right? As you have seen above, we confirm the lines are skew. Okay, that will be part A of the question. Now let's solve part B. So here we have to find the acute angle between the directions of the two lines. So pretty easy. To find the angle in between, we have to use the directions. So line 1 has directions. What? Direction is 2, minus 1, 3. And then line 2 has direction 1, minus 1, and 4. Okay, so basically the vector at the end here, after the constant here will be the direction of those two lines. So by definition, it is the dot product is equal to what? The direction number 1, direction number 2, times cos of the angle in between. So this is the magnitude of those two. So let's find those values as well, right? So first we have to perform the scalar product. So 2 times 1 is 2, plus minus 1 times minus 1 is 1, plus 3 times 4 is 12. And that will be what? This will be the magnitude of the first one. That should be, let's find out. We have 4 plus 1 plus 9. That should be 14. And this one will be 1 plus 1 plus 16. That should be 18. That will be cos of theta. So we have 2 plus 1 plus 12. That will be 15. And here we have this and this over cos of theta. Now we have to make this become subject, so cos of theta has to be 15 over this and this. Let's see what happens. So 15 divided by root of 14 times root of 18, that will give me this value, right? 0.945. So finally, so this is cos here, right? So theta will be cos inverse of that value. Let's see what do we get for the answer. Has to be in degrees if you want to. That will be 19.1, correct to 1 decimal place for the answer. And that will be your question number 7. Okay, so now let's move on to question number 8. The complex numbers u and v are defined by those two. This is given to you by the question. Now part A, we have to find u divided by v in the form of this, where x and y are real. So pretty easy, one by one. So let's replace u up here. You have u is on top, and then v is at the bottom. That will be 3 plus I. Now, how do we simplify this kind of ratio? We have to multiply. I think we have seen this in thirds as well, right? So I have to multiply by 3 minus I and 3 minus I. So multiplying by its conjugate to simplify this kind of fraction. So that will give you what? On top you will have minus 4 plus 2i times 3 minus I over 3 plus I times 3 minus I. Now simplify one by one. On top, take this one, multiply this, you will have minus 12 plus 4i plus 6i minus 2i squared over the value of, that will be 9 minus I squared. Simplify, let's see what happens. So here we have minus 12, that should be what? So minus 2i squared is minus 1. So minus 12 plus 2 will be minus 10 plus 10i over the value of 9 minus minus 1, that should be 10. So simplify, that will be minus 1 plus I. That will be u over v in terms of this form, x plus iy, x plus iy. So as we can see, the I is here, y is basically 1. So this is the same thing, right? So this is the answer for part A of the question. Now for part B, we have to express u over v in this form. So pretty easy. Now to find r is what? R is the integration, it's the square root, square root of this part and this part of the value. That will be minus 1 square plus 1 square. That will be 2. That is easy. Now we have to find the value here. This is the argument of u over v. Now as we have seen, u of v is equal to what? Minus 1 plus I, that is the value of this. Now again, if you want to, you can use logic. You can always find step by step. For example, here, what is this complex number? What is this point? So you have your axis here, right? So minus 1 should be minus 1, and I will be somewhere over here. So we're trying to find, so if you join this, now the argument of this is what? It is this value right here. We're trying to find this angle. That makes sense, right? Now to find this angle, we can reverse engineer this value. So we can just first find this one and take 180 minus this to find this. Now what is this angle? If you look, this is a right angle triangle. This is 1 and this is 1. So to find this angle, pretty easy. That will be, if you observe, that will be what? Tan inverse of the value of 1. That should be 45 degrees, which is pi by 4, right? Because by SOHCAHTOA, it will become this. If you can try step by step, you will realize that because we have a right angle triangle, we can use SOHCAHTOA, and then that will become this value right here. Now to find the red part, it has to be what? The whole thing is pi minus pi by 4. That will be 3 pi by 4. So as you can see, we have the two values that we need. So u over v can be root 2 exponential I 3 pi over 4. Okay, that will be part B of the question. Now let's move on to the next part. Now here in the Argand diagram with the point O and the points A, B, and C representing the complex numbers u, v, and 2u plus v. So let me write those points down. So u was given to you by minus 4 plus 2i. V was given to you by 3 plus I. And then we have 2u. So 2u is 2 times minus 4 plus 2i. And plus v is 3 plus I. That should be what? Let's see. We have minus 8 plus 4i plus 3 and plus I. That will become minus 8 plus 3 plus 5i, which is basically, this is minus 5 plus 5i. Okay, so we have those 3 points. So this is the point A, this is the point B, and this is the point C that we can actually draw on the Argand diagram. So in this case, let me see what can we do. So here we have this. So we have to state the geometric relationship between OA and BC. Now step by step, in those cases, since we have to state the geometrical relationships, we can try to make this kind of accurate to see what's happening, right? Because we have to use that diagram to see what can we derive from that shape. Okay, so here we have, so the first is minus 4 plus 2. So let's say minus 4 is here, plus 2, that should be, let's say, somewhere over here. That's the point A, for example, that is minus 4, 2, I. And the point B is 3 plus I, so 3. That was 3 here. I is what? That will be I right here. That's point B. Now point C is what? Point C is 3 plus I. That will be, sorry, this is C is minus 5, 5i. Sorry about that. So 5 minus 5 will be, this is minus 4, minus 5 is here, and 5i will be what? So here we have 2, that will be 2, 4, and 5. Somewhere over here, that will be 5i. So 5, that will be my point C. Now let's see what can we derive from the points. So here we have what? The first line is OA. OA will be this one, from the point O going to A, right? And then we have BC from the point B going to C. Okay, so here we have these two. Now, what is the first thing that you can kind of realize? So it is kind of, I would say it is kind of parallel. Let's see if that is true or not. Because what is the direction BC, right? BC will be from OC minus OC will be this point, which is minus 5 plus 5i minus OB. OB is 3 plus I. So just to confirm, right, we never know if it is exactly parallel or not. We want to confirm using calculation sometimes to see exactly if that is true or not. So we have minus 5 minus 3, that should be minus 8, plus this minus I should be plus 4i. Now OA, it is equal to minus 4 plus 2i. Now as you can see clearly here, that is, we can see that OA is equal to what? Half of BC, right? So by showing this, we can confirm that first thing is OA and BC are parallel because they are multiple of each other. That's the first thing that we can conclude. And also you can see that OA is half, or you can see BC is 2 times OA according to this thing. So this is very easy. You can derive this very easily because OA is minus 4 plus 2i, right? And BC is minus 8 plus 4i. As you can see, if you factorize outside the value, you will factorize what? You will factorize the value of half, so that this becomes the value of minus 4. So because how can you make this become this? Divide by 2. So you're taking the value of half right here. That's how you can form this equation. Either way, those are the two main points you can derive from that diagram. And of course, if you can show this as well, it will be very helpful for you to confirm the answer to yourself that this is true. Now for part D, we have to prove the angle AOB is this. Now where is AOB? So we have this. This is O. This is this, and we have this one. Okay. So let's see where is that angle. So we have to find angle AOB, which is this one. Okay, so the first thing is by observation. How would you find this angle AOB? You can take the whole thing minus this one, which is the argument of A minus the argument of B. But now if you realize that A is represented by U, so argument of U minus the argument of B. B is V, right? It's the same thing as saying argument of U over V. Now again, this, we have done this before. If you do see this here, right here. So when you have to find the argument of U of V, you got the answer of this. So same thing here. It will be 3 over 4 pi from part B. We derived this already. So that will be part D of the question. So that will be your question number 8. Okay, so let's move on to question number 7. So here we have let f of x equal to this fraction for x is more than 0. That is a condition we have to keep in mind while doing this question. Now, the equation x equal to f of x has one root. So he has one root. It is denoted by the value of a. Okay, good to know. Now verify by calculation that a lies between these two. So pretty easy. Now for x equal to the value of 1, let's look at the values on the left hand side and the value on the right hand side to see what is the difference, right? So let's write this down. So on the left, as you can see, we have what value? We have the value of 1. And on the right, we have the value of what? So let's replace. You will have exponential 1. So 2 times 1 will be square plus 1 divided by exponential square minus 1. That will be the value of 1.31. And here for the value of x equal to 1.5, let's look at the value on the left hand side and the value on the right hand side. That should be 1.5, x is 1.5, and the f of x will be this one. So again, let's replace back. You will have what? exponential power 2 times 1.5 is 3 plus 1 divided by exponential power 3 minus 1. That will be 1.104. Now as you can see here, this one was less than this one was more than this one. Now because of this, since there is a sign change, as you can see, we can confirm that the value of a lies between the value of 1 and 1.5 by showing this. Now again, if that is not enough, you can always show the difference. So let's take this minus this, for example. So 1.31 minus 1, that should be 0.31. That is a positive value. And we can also show this 1.104 minus 1.5, that should be minus 0.396. We can also see there's these two sign change with the difference of the left hand side and the right hand side. Because of that, again, we can confirm that a lies between 1 and 5. So two ways to confirm, same thing, same idea, but we have to show some kind of calculation. That will be part A of the question. Now for part B, we have to use an iterative formula based on the equation in part A, okay, to determine a correct to 2 decimal place. Now, as you can see, in part A, x was given by exponential 2x plus 1 over the value of exponential 2x minus 1. Right. Now, to begin with the value of x, so we have to use x1 is equal to what? Exactly between those two, so that will be what value? So 1 plus 1.5 divided by 2, that will be the value exactly between, which is 1.25. Let x1 be 1.25, sorry. So x2 will be what? So let's do this. So 1.25 will be the answer for the first one. Then we just have to replace back in the formula. That will be exponential. So we have to put bracket first because of the fraction. So we have exponential 2 times answer plus 1 divided by, then we have exponential 2 times answer minus 1. That will be 1.18 x3. It says giving each answer correct to 4 decimal place. So let's try again. So 1.1789789. Then we have 1.2091. x4 will be 1.9560. x5 will be 1.2015. x6 will be 1.1989. So let's see, where do we stop? So giving to 2 decimal place. Okay, so let's try a few more. Why not? You have x7 will be 1.2000. As you can see, correct to 2 decimal place, the value of a will be what? Will be 1.20. That will be the answer for A. For part B, using this iterative formula to solve this value. Now these questions are not very hard, so I think you have to maximize your points in those kind of questions. Okay, now let's move on to part C of the question. So here we have to find f prime of x. Now f prime of x is simply, we have to differentiate f of x. Now f of x was given to you as exponential 2x plus 1 over the value of exponential 2x minus 1. Right. Now the first thing we realize is that it is a fraction. So in that case, we have to use the quotient rule. So that will be f prime of x. That will be, first we write down the denominator, this one. Now again, this is a formula that I'm using for the quotient rule, right? And multiply by dx of this one, that will become exponential 2x times 2, then minus the numerator, and times d by dx of this one, that will be exponential 2x times 2. Okay, so divide by the base square. That will be this and square. Okay, now let's simplify to see what happens. So here we'll have 2 exponential 2x, and we have exponential 2x minus 1. Here we have minus 2 exponential 2x, exponential 2x plus 1. Over the value of this one is exponential 2x minus 1 is 2. Now again, you can always simplify this some more to see what happens. For example, I can factorize these two outside. For example, let's take out these two, and on the inside you will have exponential 2x minus 1. Here we have minus exponential 2x and minus 1. That will become what? These two will cancel out. Minus 1 become minus 2. That should be minus 4 exponential 2x, and over the same value here, which is exponential 2x minus 1 square. This is f prime of x. That is the first part of the question. Now, we have to find the exact value of x when this is equal to minus 8. So let's find out. Let's equate that to minus 8. You will have what? First thing first, we have to cross multiply. You will have minus 4 exponential 2x is equal to minus 8 exponential 2x minus 1 square. Now, these two can cancel out. Have 2 here. You have exponential 2x will be 2. Expand these two, you will have what? Exponential 2x, that will be square, right? And minus 2 exponential 2x, and plus 1 will be this. Now let's try to simplify and see what happens, right? So on this side you will have exponential 2x is equal to 2 exponential 2x square minus 4 exponential 2x and plus 2. Now let's send everything to one side. Okay, so that will become over here you will have 2 exponential 2x square. So here we have minus 4 minus 1 become minus 5 exponential 2x plus 2. That should be 0. Now again, if this is confusing you, what can you do? We can always try to let u become exponential 2x. So you will have 2u square minus 5u plus 2 has to be 0. Now as you can see, this one is a more simple quadratic equation that we can factorize very simply. That will be 2u times u. This is 2 times 1. Now to get minus 5, we have to have minus 4 minus 1. If that makes sense, right? So u has to be half and u has to be the value of 2. Now again, we do not care about the value of u. We want to find the value of x. So replace exponential 2x have to be half, exponential 2x have to be 2. So 2x have to be ln of half, and x have to be half of ln half. Or here we have 2x has to be ln of 2, x have to be half of ln 2. Now let's see which one is the correct value, because as you can see here, we want to find the exact value, which is only one of them. And let's see what happens here. So what is ln of 0.5? It is a negative value. So this is negative value. And as you can see here, x has to be more than 0. That is the main thing that helps us choose the value of x from the question. So we have to use this one as the value of x. That will be x have to be this, or you can write this in this way, 2 power half, which is the same thing as ln of root 2. Okay, and that will be the value of x, for which f prime of x will be minus 8. And that is your question number 9. Now let's move on to question number 10. So the diagram shows the curve y. Okay, this is the curve y equal to sine 2x cos square x. Okay, great. Now for this domain between 0 and half pi, which is 90 degrees, and its maximum point M. So this is the maximum point of the curve, right? Now for part A, we have to use the substitution u equal to sine x, find the exact area of the region bounded by the curve and the x-axis. So we have to find the area below the curve. Now, one thing we know, How do we find the area? We find the area by using integration. The limit is this one, which is half pi, and this one, which is 0. And we have to integrate the value of the curve, which is sine 2x cos square x by dx. So because here, as you can see by the question, it has helped you already, we have to use u equal to sine x. So let's see how can we convert this whole thing in terms of sine x, right? So let's see what can we use here. Now, if you realize, what is sine 2x? It is a double angle here. That will become 2 sine x and cos x, if that makes sense, right? And now what is cos square x? That will be 1 minus sine square x. Okay, as you can see right here. Now let's replace the values in the equation. Let's see what happens step by step. So here will be the same thing, right? It does not change. Now replace the first one here. Sine 2x will be 2 sine x cos x. Then multiply by the value of what? Cos square x, that will be 1 minus sine square x by dx. Now let's try to expand this, right? Let me do this on the side, right here. So that will become what? So 2 this times this, right? So first one will be 2 sine x cos x minus 2 sine cube x, and then that will become cos x dx. Okay, so right now we have this, for example. Now let's see what else can we do, because we will have to try your best to simplify everything. So we can take out the value of what? Let's we take out the value of cos x. You will have 2 sine x minus 2 sine cube x. Now we take out the value of cos x because they are common in each other. And of course the limit is half pi and 0. Now let's try. Let's see what else can we do. Now we can begin by using the substitution of u equal to sine x. So if u equal to sine x, du by dx will be what? Will be cos x, which means dx have to be du over cos x. Now simplify. Now again, because usually what I do is, because we have used u to be sine x, in most cases you can also change the limits, okay? Because in that way you can always do that, so you can do the integral directly, if that makes sense. Because usually what happens is you have to convert back to x and then use these two to find the answer. However, you can always just do this. Because we know u is this, let's replace those as well. Now when x equal to half, what is the value of u? That will be sine of half pi. That should be, in terms of radians, that will be 1. Okay. Now when x is equal to 0, the value of u will be sine of 0. That will be 0. So the new limits will be, because of this substitution, that will be 1 and 0. Again, and the reason why I'm doing this is because I know that usually when we do substitution, in order to use these limits, at the end we have to convert back to x to use that. However, you can also have the option not to do so. By changing the limits to u, then we can solve it directly. So let me show what I mean, right? So here we have what? So here we have 2 sine is u minus 2 u cube. And that will be cos of x. And dx is du over cos x. Right. Now we can simplify. These two will obviously cancel out. And now, as you can see, this is a very simple integration in terms of u with respect to du, and the limits are also for u. In that case, we can solve directly to find the area. So 2 is only a multiple. Take this outside. You will have what? 1, 0, u minus u cube du. That will be 2 u squared over 2 minus u power 4 over 4, limits of 1, 0. Now simplify. You have 2. That will be 1 over 2 minus 1 over 4 minus 0. That will be 2. And that will become 1 over 4 as well, right? Because half minus 1 over 4 will be this, and then times 2, that should be half. So your answer is 0.5 units square for the area under the curve for this curve. Now this is part A of the question. Okay? Now let's move on to part B of the question. So part B, again, we have to find the exact x coordinate of M. So let's see. We know that M is what? M is the maximum point. At max point, or at the stationary point, what do we know? We know that dy by dx have to be 0. So that's the first thing we have to kind of think about. Now, we know y has been given to you by sine 2x cos square x. Okay? Now by observation, you can see that this one is clearly a product, right? So in that case, we can use the product rule to find dy by dx. That will be dy by dx will be what? We can leave the first one by itself. That will be this. Then d by dx of this one will be 2, power first, so 2 cos x times minus sine x, then plus cos square x, then d by dx of this one will be 2 cos 2x. Now simplify, let's see what happens, right? So on top we have what? We have sine 2x multiplied by minus 2 sine x cos x. And then we have plus 2 cos 2x and cos square x. So this is basically the first thing we have right now for dy by dx. Right. Now let's see how can we simplify this some more to find the other values. Because here we have double angles. As you can see here, we have to find ways to simplify this. Now what do we know? We know that sine 2x is equal to what? Is equal to, this value here is, as we know, it is 2 sine x cos x. Right. And also, what do we know for this one? Cos 2x is what? It is equal to, we can choose, we have a few options. It could be cos square x minus sine square x. It could be 1 minus 2 sine square x. Or it could be 2 cos square x minus 1. As you can see, again, at first I don't know what to do. I don't know what to choose. I have to observe which one can I choose to make this, to simplify this equation and have this make sense for me, right? So that's my main thought right now. So let me see what is possible for me to use so that it makes sense. So let me first simplify this one. So this one you will have, this is become this, so this time this will become minus 4 sine square x and cos square x. Okay, and here we have plus. Here we have 2. And cos 2x we can have what? Let's see, cos 2x we can have, we can choose which one. Let me try to choose this one, why not? Let's say we begin with this one. We have cos square x minus sine square x and times cos square x. Now this is dy by dx. We have to equate to 0 at the point M because we know that dy by dx is 0 at the point M. Now the next step is we can send this one over here. You will have 4 sine square x and cos square x is equal to 2 cos square x. Now become cos square x minus sine square x. Right. Now this can simplify out, as you can see here, very simply. And divided by 2, that will become 2 here. So we have 2 sine square x is equal to cos square x minus sine square x. Right. Now let's send this over here. That will become what? 3 sine square x is equal to cos square x. Now divide by cos square x everywhere. So as we have seen many times before, whenever in an equation we have sine and cos, we divide by cos. Why? Because you will see it will become What is sine over cos? That will be tan. And here, because we have square, that will be tan square x. And this will be 1. So tan square x have to be 1 over 3. If that makes sense, right? Now we have two possible values, as you can see. Tan x will be root of 1 over 3, of course, plus or minus. Now, again, because the value of x is in the, according to the question, it is between 0 and half, it will be in the first quadrant. So we can only take the positive value of tan x. So tan x can be plus 1 over 3. So x have to be tan inverse of 1 over root 3 for the exact value, right? So let's use degrees to see. Tan inverse of 1 divided by root 3, that will be 30 degrees, which is same as pi by 6 radians. So the reason is because x is between the values of 0 and pi by 2 in the first quadrant. So because of that, we'll take the positive value of x, and because of that, we'll take the value in the first quadrant to find this one. Okay, so finally, the value of x has to be pi by 6 radians, obviously. Now, as you can see again, in this kind of questions, we don't know exactly what to do at first, right? We have to try one by one, see how can we simplify this too, and then eventually find a way to find the answer. So that's the main point I'm trying to make, is that, okay, no matter who you are, we don't know what to do at first. We always try to find a way, simplify, and see how can we derive the answers. Now, this is the last question of this paper. And what are my conclusions on this paper and regarding the next paper coming up for you guys? So I believe for the May-June session, it will be not much, maybe more difficult than this one. This one was pretty simple, I must say. The question was pretty direct, and there were not many tricky parts, I would say, in this paper. So if I was you, I would expect more tricky questions for May-June paper. However, the thing is that if you understand the basics or the fundamentals, you should be able to do any questions, because there will be many times you will see a question that you've never seen before. However, if you take time to understand the question, and if you understand the basics, you will find a way to do the questions. So always remember that any question they will give you in the exam, you can do this, because it is everything you know already. Okay, now with that being said, thank you for watching, and I will see you soon.